Hello again. Let's start this chapter 2 on this journey to create an artificial intelligence system able to play music. Okay, so first of all, let's make some crop up. Let's see where we where we got last week, where we arrived, and see which are the next steps, and see which are the main goals, so the main in the short term. Okay, so what we did last week was a very simple task, but very crucial task, which is first of all we define what is a musical note. We define what was the different type of notes with with four properties, which is pitch, the pitch, the duration, the intensity, and also the timbre. And what we did is just okay, we have 7 notes. So let's play them randomly. So we create a sequence of music, a sequence of notes, and with that we were able to listen some music. So what we did basically is just to create the the most basic stuff to play music, which is standard notes, a sequence of notes, which is a melody, and finally listen to it. But instead of saying what are we going to see now, what I'm going to do is I'm going to present the whole project and just to tell you which are the main steps of this project, and then I'm going to to continue with the development of this project. So first of all, we are here. We are developing the music architecture. We are creating the notes, the sequence of notes, the melody, and also today we will be creating the tonalities. And tonality is a concept that is crucial in music. So what we are doing now is just to implement the basic or the most standard concepts in music theory, and we will be finishing this by the end of this month, which is actually this week. So by the end of September, early October, we will be finishing this. So next step is okay, we are going to use neural networks. We're going to use long short-term memory neural networks, and what we are going to do is, since we know how to model the music in terms of different notes and how they are structured and all that, we are going to read music from standard composers such as Beethoven, Mozart, or also even U2 or Coldplay and all that, and we are going to learn from them how they create music based on different sequences. So first of all is to use recursive neural networks and long short-term memory algorithms to learn music from composers. So we are able to imitate styles. But that is not the only thing we're going to do. We're going to learn also how to structure the music, how to create different structure, and also how to create different sequences. And this is what we are going to do also. So then the most important thing is this one, which is sorry, because it is loading. The most important thing is this one. We are going to use generative adversarial networks. And why? Because we know how the music is composed. We know that there are many different types of music that has been already composed, and we are going to assume that can maybe start a discussion on what is good or bad music, but the bad music will be just a randomization of the good music. So we will be using GANs network just to make that in the same way they are being used for training images and in order to detect cats and dogs on images. Okay, so we're going to use that strategy and to see if we are able to create one black box, one box being able to predict what is good or bad music. And then the next step, close to November and December, is okay, we're going to use genetic algorithms just to create different sequences of music, because if we want to maximize the previous model, how we are going to create that music? So we are going to combine genetic algorithms with long short-term memory algorithms and neural networks, and we are going to maximize that previous predictive model. And then the last step, just in December, is just to relax and to listen some music. So these are the main 5 steps, which is music architecture, to learn music from different composers, just the melody and also the sequences, to create one predictive model saying which is what is good music and what is bad music, and finally to use genetic algorithms. So you will learn all these 3 steps and how to implement this in Python. But today we have to still working on the architecture, on the basics, and we are going to present today what is the tonality. And today we're going to implement tonality. Tonality is something that is learned on the 3rd and 4th course of music. It's something quite difficult to explain actually, and it's also a bit difficult to understand. And even if I play something on let's say on tonality A, and then I play it on tonality B, maybe if you are not trained, you are not going to even notice the difference. So it's quite difficult even to distinguish. But tonality is something like this thing that we have on the right, which is we have the same picture, which is if I don't remember, but which is I think it's Marilyn Monroe. We have that picture, and we have different types of proportion between the colors. And if you look, for example, at the red one, maybe you like it more than the one on the left, the one on the right, okay? So the tonality says how those ingredients fit, or how those colors fit, but applied to music. That is tonality, that you can play the same melody but with different tonality. And why is this used? Why? Because sometimes you need to transpose. For example, sometimes that happens very often. You try to sing a specific song from your favorite singer, from your favorite music group, and you cannot sing it at home, okay? Because you don't have the voice to sing it, but you select a lower tone, which is I can sing it on a lower speed. So in that case you can sing it, okay? So that is the tonality. It actually defines the relationship between the notes and the intervals. If we have a similarity on the nature, it is something like the gravity. The gravity defines how the planets and the stars behave among them, but you don't see it. So it is something similar, okay? And then this is the last comparison, okay? Imagine we have 3 numbers, which is 1, 3, and 7. The way you combine them is going to give you different numbers and different value. It is not the same 371 than 731. Okay, it is not the same. So tonality says which notes are more important than others on a specific scale. So the tonality is saying in this tonality, for example, the note fa is more important than the note do. Okay, that is what tonality is saying, that some notes are more important than others, and this is what we are trying to model today, okay, on the programming session. And this is, let's say, this is a structure, or this is described theoretically by this by this scale, and I'm going to explain every single thing here, okay? So the tonality says that if we select the first note, which is do, this tonality is major do, okay? This is do major, which means that it starts on do and it ends on always on do, okay? And all the different grades, all the different notes, which is do, re, mi, fa, sol, la, si, do, they are renamed with specific grades. And a grade is this number, which is on a Roman scale, which is you have first grade, second grade, third, fourth, fifth, and so on. And you will see that there are many that are on a capital letters and many others that are on a lower letters. So it means that those that are on capital letters, they are they are called major chords, and those with lower letters, they are called minor. The difference between major and minor is that it is like it sounds happy or it sounds sad. For example, major song, okay, like this chord is going to sound like happy stuff, like like happy birthday. That is happy song. But if I play these chords here, they are going to sound like sad music or unhappy music. Okay, that is what it comes to our mind. And then we have also this name here, which is how these notes are called within the tonality, which is we have do, re, mi, fa. All those have a different function. For example, the main note is the tonic one. So on a tonality, the tonic is the one that is more repeated, is the most repeated note actually. And we have also the subdominant and the dominant. So like 1, 4, and 5, they are the most repeated grades on the scales and on the music. And this happens all the time. This happens in YouTube, in Coldplay, in Guns N' Roses. It happens always in all type of Occidental music. Okay, and why it is called these names? Why? Because if we use only tonic, subdominant, and dominant, only with 1, 4, and 5 grade, we are able to make music. Actually, the canon of Patchwell that you have for sure listen uses only few of these notes. They are not using all the notes from the scale, and this W here that we have W and a half W means that from this note which is Fa to this note which is Sol, we have one tone, one difference tone, which is that there are 2 half tones, and between Mi and Fa and Si and Do we have only half the tone. So the tonality is defined by this sequence, which is one tone, half, 1, 1, 1, half. That defines the major tonalities. And since this starts on Do, that is the tonality of major Do. Okay. And as I said before, the most important thing is that when we try to learn music, when we try to use, for example, LSTM or RNNs or these kind of neural networks, usually what is done, even by Google, is just to create sequence of notes, of random notes. So you read one specific piece of music and then you learn the sequence of notes. But what is important is this structure within the music. It is not the same a Do within a tonality of Fa than a Do on a tonality of Mi, for example. It is the same note. It can come after, let's say, after Si, after Re, after any other note, but the function of that note changes. And this is something that is not being collected in the state of the art of all the models that are being created based on artificial intelligence. And this is something that, in this case, in this project, we will implement this, because I think that is the way. Because a composer has the ability to find which are the sequences of grades that are more funny or that are more nice to the user, rather than thinking of the notes. Okay, and in order to illustrate what means one semitone, half tone, and a single tone, if you go to a piano, you can see that between Do and Re, you have here Do and Re, there is a black note here. That means that from Do to Re you have one note in the middle, and that is the half tone. That is the reason why between Do and Re there is only one tone. If you go to Mi and Fa, there is no single tone here, so that is the reason why from Mi and Fa you have only half tone. Same from Si and Do. So if you play all the white notes on a piano, you are playing the tonality of Do major. Okay? And then, and this is the end of the theoretical part, is that not all the sounds are allowed. So if you are playing on the tonic and you are playing several compasses and several bars and several time on Do, you cannot play any note. You can just play all these three notes of Do. And same happens when you are in the second grade or in the third grade or in the fifth grade. So you cannot play anything. There are some rules that makes the music listenable or that makes the music nice to the ear. And this is something that is very difficult to be extracted from the music itself. This is something that is learned from the experience, that is learned from the theory, that is learned from composing during centuries. So what is important and what we are going to implement is that we're going to work on sequences as we have seen before, and we are going to allow only 3 notes for every specific grade. So what we are going to do is we are going to define one sequence, and we are going to play only that single sequence, and we will see if that makes better music or not. Okay? So today we're going to make only 3 things, which is we are going to start the tonality class, implementing all the basic rules that we have seen here today. We are going to create that music based on grade sequences rather than only sequences of random notes. And again, since we have some functions already to play music, we will see if there is a difference and if that sounds better or not. Okay, but for sure you don't have to learn all these chords by heart, and you don't have to now be careful, because what is going to be learned from the recursive neural network is the sequences that are repeated within the music rather than the notes, and those sequences is what we have to infer from the different composers and from the different pieces of music. So now, yes, no more talking, and it is time to program. I have habilitated somehow the chat, and I will see if someone is saying something. Okay, so now I'm going to shift to the Sublime. So the idea now is that I'm going to increase the size of this. Yes. So now, as we did last week, we have already implemented the musical notes, the melody, and the play class. And the most important thing on the musical note, and this is something that I made on the during this week on the background, is that on the musical note, if we go here, I have created one method which is going to give us here the major chord. Okay, so given one note, I have already implemented which are the notes that are allowed and that are not allowed. Okay, so this is something that I'm not going to explain in detail, because it is more about music rather than programming. But just to keep in mind that it's something that is already there. So before starting and before I forget, here on the GitHub, you can see all the issues and all the tasks that has been already done. So concerning those done, you can find, for example, that I have made how to implement major, minor, and these chords, okay, and how to implement chords based on a specific note. You can read the issues. And today we are not going to make the test. This is something that I always do on I always do offline. We're going to implement the class tonality, and this class tonality, it has all the requirements that we have seen before. Let's see if it's open or not. Otherwise, I will move to the code. Yes. So we have to develop the capability to apply the same tonality to the music piece of work, which is what we are looking for. So yeah, now we're talking, and let's the code talk. So the tonality is something here. Yeah, this is something that we have to create from scratch. And as we have seen before, in tonality we have two types of tonalities, which is the major and the minor. Okay, if the major is difficult, the minor is, let's say, like 10 times more difficult. So today and probably in the next month, we are only be focusing on the major, and probably I will do the minor on the background because it requires more deeper understanding of the music and of the grade. So the idea is that today we're going to implement just the class tonality. Okay, for now it will do nothing, and then the class major, which will extend the tonality. So since the tonality defines the class tonality defines the structure of the music, and also to the relationships between grades and notes, and also which is which is the tonic dominant and the function of every note. Okay, so for instance, here in the major class we have to talk about the different functionality, different chords, okay, because of every functional note. For example, as we have seen before, yeah, let me say it again. As we have seen before, this structure here is specifically for the major tonality. So in the tonality, I cannot implement that the tonic and the subdominant are major chords, neither the median or the supertonic are minor chords, because this is something that is specifically for major classes. So that is the reason why that must be on the major class. Okay, so the different chords of every function note must be here. Okay, and also how to, yeah, this is the second step, which is how to create music from chords, and which is functional notes is the second grade, and so forth. Okay, so the idea of now of the tonality is that we have to define the constructor self, okay, and we have to give them, the tonic, which is the tonality depends on the note. So if we have the tonality of mi, it relies on me, it depends on me, and it depends also on fa, on sol. So we have to say which tonality are we talking about. Even if it would be major or minor, we have to give a specific note. So in that case, the tonic is the main note, and this must be set as a parameter. Okay, so additionally we have to give the set of different tonalities. For now we are going to give only the most basic tonalities. There are some other tonalities such as do sharp or re sharp or sol flat for sure, but for now we're going to focus only on the most simple one, which is the one that you are seeing now. And now if I want to reorder, because it would be easier to arrange the vector of tonalities based on the tonic one, which means that, for example, for instance, if the tonic is mi, I need the self tonalities to shift in order to make something like this. Well, this can be see actually. So this is what I have to do now, because that will make very easy later on to compare to the grades 1, 2, 3, and so forth. That is the reason why I'm doing this. So there are two different types of ways of doing this. One is using the collections import way that I have done here. So this is something that, well, in my opinion, it's not the best way, but yeah, I would like to present it to you. So first of all, let me run this at the end, which is if name is equals to name. Okay, then I will call to, and I will say do here. Okay, so that we can be testing this. So if I print self tonalities and I take the index of do, if I do this, okay, I don't know why I take that much. It is not that difficult to do this, okay? But it says that the position is 0, and if I say sol, probably it will say, sorry, it will say 4. And why? Because with the index of a vector, I'm able to select, for which is the position of this element within the tonality. So that actually helps a lot in order to find, the position, in order to shift, to shift this. But the way the que works is that you just say the que self tonalities and you print this, you will see that it is just an structure. Okay, and yeah, so it just says that the sequence is do, re, mi, and so forth. So the idea now is that if I do something like this, which is rotate A, so that I use the minus so that it goes in the other direction. Okay, if I do this, I will be sorting the vector sol tonality in the way I want, which is sol, la, si, do, re. But for me, this is, kind of complicated, and you have to use also external libraries that I don't like that much. So my favorite way is just, first of all, find the index of the tonic within tonalities, and this is something that we can do like this. We store these tonalities dot index tonic. Okay, and finally, if we use a Pythonic way of doing this, is just as simple as that, which is you just call the self tonalities, okay, and yes, say something like from index tonic till the end plus self tonalities till the end to index tonic. So let's see if it works. So in just one line, I have done the similar stuff. Okay. So in this case, yeah, the tonic is do. That is the reason why. But if I do this, it must give the same result. This is what I'm looking for exactly. So it gives you the capability of, reorder the array, and what I'm going to do now is I'm going to call this self grades. And why self grades? Because now these are the grades of the tonality. It's not just a simple sequence of elements. It's just the scale, the main scale of the tonality. Okay, so we have already ordered the sequence. We have everything almost done. But what is important now is that since we are going to use the names of the sequences grades, such as tonica, supertonica, okay, and so forth, we need to create a mapping saying that the one is the 0, okay, the second one is the 1. And why? Because later on it is much easier if I just type the sequence grade rather than the number of the array, that is not very musical. And if I use, the first grade, second grade, that is actually more similar to music. Okay, so yeah, I'm just finishing, and this is the last grade. This is 6, and this is called, and I will call it something like, this is a dictionary grades positions, and this is, very helpful, because now later on, if I want to find, for example, which is the if I want to find which is the main, the main chord of a specific grade, I can do it. I can do it this way. So finally, what I'm going to do is something important for the tonality is which is the tonic note. Okay, and this is something that we can extract diagonally. So actually, I can just say, okay, this is the index tonic. Okay, index tonic, sorry, grades element 0, and that's it. But it's not that, because actually, if I want to create this as a class, not only as a as a name or as a pointer, I have to use globals and to use this structure. So globals, then you have kind of an array saying that the name of this thing, which is the tonic, and then brackets, that creates actually a specific class, and we can see this way. Okay, so let's forget already about this. Okay, so this will give us one class, which is this one, okay, which is sol, and this is a class. If I don't do this, if I just print, for example, this thing, it is going to give us different thing. Actually, I won't be able to call any different parameter. Okay, so I don't want sol, yeah, that is the name of the tonic, even I don't need it. that is not so. What I need is just, you know, the tonic. And if I think, well, I think I can even save. Yeah, let me check, because I think I can even save this and just type tonic here, which probably is much easier. Yeah, it cannot be done. Yeah, because this is just a string. Okay, perfect. So yeah, we are finished with the tonality class. The only thing that remains is just to define a get tonic method, which is useful many times. This is going to give the tonic. So this is it, and this is how, you know, the tonality works. Let's see if everything works properly. And tonal, I will say print tonal get tonic and see if this works. And if it works, we are finished with the tonality class. Yeah. So now it is time to implement the major class. And how can be this done? Well, you know, in order to do this, in order to create that major tonality, we need to create this sequence, which is, if this is the major tonality, we have, yeah, let me swap the window, sorry. Yeah. So now, yeah, we have major chords are 1, 4, and 5. Okay, so that is something that we have to type. And 2, 3, and 6 are the minor, and the 7th, you see a small circle on it. That means that is a diminution, this kind of a diminished chord, okay, which I'm not going to enter into detail what does it mean, okay. So the idea now is that focusing on the major tonality, it must define this specific property, which is self major chords are, and now it's quite easy because I can make, yeah, musical reference to it, okay, which is 1, 4, and 5th. If we go to the minor chords, they were 2, 3, and 6. Okay, and the 7th one is called this, the diminution chord, and that is only the 7th one. We'll do this for clarity. Yeah, sorry, you won't see nothing. So what I have done is just to type the different major chords, which are 1, 4, and 5th, and the minor chords 2nd, 3rd, and 6th, and finally this chord is the 7th. So this define a structure, okay? This define a structure that is specific for the major one, okay? So now, if we just call the constructor of the father, okay, and with this call init, and the parameter is tonic. Yeah, that's it. So with this, and if I do something like this, okay, now nothing is going to happen rather than tonic, but yeah, it has worked. I have some properties for this do major scale, okay. So now it comes, you know, the nice stuff, which is I'm going to create a musical sequence, okay. So if I create musical sequence such as 1st, 4th, 5, and 1, and you have to believe me in this point that this is one of the most common sequences in music, actually, yeah, this one is like the ABC for the music, which is the tonic, dominant, tonic, subdominant, dominant, and tonic. And this is really, believe me, this is used, for at least 5-6 centuries, and it is now being used actually for current composers, because otherwise this is not going to, to be to sound great, So the idea is to define, I will call it create from sequence of grades. Okay, and for now I'm not going to put any parameter, because for now, since I'm testing this, I'm going to create the music here. Okay, so I need a musical sequence, and now what I just need is, okay, let's iterate. Okay, and now for fun, let's see that it works. So let's iterate every single grade. Okay, so the first thing is iterate every single grade within the musical sequence. Okay, and yeah, I have to somehow do this. Yeah, it won't work. And the second thing is extract for every note the corresponding chord, as we saw on the slides. And finally, on the third point is play random music only with those notes within the chord. And finally, this is the AC, which is concatenate all the values, all the notes. Okay, so basically what I have done is, if we come back to the slides, what I'm going to do is I will play 1, 5, 1, 4, 5, 1. So I'm going to do, when I play 1, I can only play do, mi, sol. Then it comes 5, I can only play sol, si, re. And then it comes 1 again, do, mi, sol. And here, when it is the time for that chord, I only will play 3 notes. And I will repeat, maybe I can play 16 notes or maybe 20 notes, but all of them will be do, mi, sol. Okay? And same with 4, 5, and 1. That is what I am implementing here. So the idea is that now that for every grade that it has been printed here as expected, what I'm going to do is, okay, so first of all, from the div grade position, just tell me the grade. Let's print this so that you can see what I'm trying to do. So since we have the div grades position, then tell me which one is, since I'm playing the 1, 5, 1, so 0, 4, 0, 3, 4, 0. That is the sequence in numbers. Because in order to know which notes correspond to this, I need to apply those numbers to the vector. So the vector says now that on the position 0, 4, 0, 3, 4, 0, I have to put these notes, which is do, sol, do, fa, sol, do. If I do this not in do but in mi, for instance, it must work for sure. And the values are the same. I mean, the musical sequence is the same, but since I have changed the tonality, then it starts on mi, si, mi, la, si, mi, and mi is the end. Okay, this is why I have to do all this. So now that I have the sequence of nodes, and I have now which node specifically I am looking for, it is time to take, as we saw before, the class, which is to create, that class, and to say this. So for every grade, I have a tonic node. Okay, I have a main, let's call it main node from grade. Let's call it this way because I think it's more comprehensive. So the main node from the grade is here, which is now the mi, si, mi, la, si, mi, and if we do this for the now, it's not going to print anything because I have deleted the command. But for do, it will be something similar, do, sol, do, fa, sol, do. Okay. So now that I have the classes, now that I have the main classes, it's time to say, okay, if the idea now is point 2, which is extract the core for every node. Okay, so now since we have here the major chords and minor chords, it is very easy, because if the grade in self major chords, so if the grade is 1, 4, or 5, then very easy, just take main node from grade, and you just go to the musical node and take the get major chord. Okay, because this is the method that I have already implemented to do this. So if the grade is 1, 4, and 5, which means is within the major chords, then extract the major chord from the main node from the grade. Okay, and let's store it here. Otherwise, this is the same, but use get the minor chord, because if it is not on the 1, 4, and 5, it belongs to the minor chord or this chord. Okay, but since I'm not going to use the this chord, it will be always on the minor. But let me do it this clean, so that I don't have to repeat it. Yeah, think, as if grade in, that is now, and this one minor. Okay, so what I have done is get the major chord from the main node, and what I'm going to do is to print the notes from major chord. Okay, maybe this is not, if I'm going to do this. Oh, what's happened? The major chords, if grade major chords. It is an error here, self major chords. Let's see if I have typed this properly. Yeah, what to say? It says if grade. Sometimes the syntax is not adequate. I'm going to say this. Oh, what is it? Okay, self-value course. And probably it's not defined. Superclass, self. Yeah. Okay. Let me come back to this later on. Let's type the code and then we will find the error. So yeah, in order to follow, which is the main idea is just to find if the grade is in the major chord as we saw before, and again also this, but for the minor. Now it is time to play random music based on those chords. Okay, so yeah, the idea is something like this, which is play random music only with notes from the chord. And yeah, this is something that is done very, very easily. I'm going to use, as we used before, which is the NP, I think I have NumPy. Yeah, I have NumPy. Random choice, and from here I will extract this thing. Okay, major chords. Okay, and I will, which means that every every time I am on a specific grade, I will play 16 notes of that chord, so that can create music. Okay, so now I just use this, taking 16, and that means that I have to repeat. And another thing I'm going to do is I'm going to create an array here, and in that array okay, I'm going to yeah, in that array I'm going to to store and to save all the all the elements from the music. That is the concatenation. Okay, so I think the mistake, yeah, was here. Yeah, now that is the reason why this one is not red. Yeah, now it should work. Yeah, I was missing one bracket. Yeah, so now as you see, the notes from the chord are, and I am playing in Do. So the idea is that I will play Do, Mi, Sol on the first time, afterwards Sol, Si, Re, Do, Mi, Sol, Fa, La, Do, Sol, Si, Re, and so on. And everything is stored, on the melody sequence. Okay, actually this is 3 and 4. Yeah, so now I have played random music and I have concatenated all the notes, and all the notes are on the melody sequence. Okay, so another trick now, and this is something that must be done, afterwards, and this is something that we have to take care as a as a musician. This is something that must be done. Okay, is that the first and last note must be the tonic. I don't care if randomly it says the first and last note is another one. First and last note must be the tonic if you want to listen this well. Okay, so the melody sequence, this is the 0, okay, and this must be the tonic. I have called it this. Yeah, this is the tonic note, but for the last one. Yeah, perfect. So the last thing is just very straightforward. We're already done, and the only thing we have to do is to add some some properties because to the nodes, because the nodes at this moment are completely naked. They don't have duration, intensity, and timbre, so we have to add it to it. So this is done very easily now, which is let's call this not props from the melody, and this is the duration, and I will say the duration. Yeah, I think what I'm going to do is forget about this. I'm going to iterate. I will say melody sequence to play. This is an array, and for node in melody sequence, what I'm going to do is to iterate and to add this property to every single node. So I will do it just to node update props, which is another parameter, another method that I have created during this time, and the duration would be a random choice, okay, between these two values, and I will later on explain you how and why those values. Okay, I will take only one value, and I will choose the 0 because NP random choice gives you an array, and I have to take the first element, and then intensity is just 17, for example, and finally timbre is 1. Okay. Yeah. So now what I'm going to do is I will do add this. Then the nodes. Okay, let's see if this works. And then I have just to return this. So now I have finished, and now let's see how this works. So now I am going to call already to the this one is just a melody. This is a melody sequence, okay, and finally what we have to do is just let me paste from the melody last week. Okay, so that because I can reuse some code this way. So now what I'm going to play is this sequence 1 5 1 4 5 1 with length 16, and I'm going to use the same duration. So now it is no sense to this. Yes, and now let's compile and let's listen to it. Yeah, so it works. Now let me open this and let's play and let's listen to it. One moment, I'm looking for it. This is the output, my device, So I'm going to open the GarageBand and I'm going to share with you the GarageBand when it opens. Wait a moment, it takes some time. 1 second. It's loading. But I think that for now I can open. Yeah, I think no. Yeah, I'm going to open now the file with the CSV so that you can see it. This file is the one that has been created, and as you have seen, we have started in Do, which is the 60, and all the time 60, 60, 64, 64, 60, 67, and yeah, let's see if opens once. Yeah, okay now. Okay now. And this is the sound we have created. But I think you cannot listen to it. Yeah, wait a minute. Yeah, sorry for the noise, but the yeah, that's it. That's it. That's it. The composition that we have done, and I have another surprise before we finish, and that surprise is, yeah, this one. I'm going to play. I'm going to use the same sequence. That sequence corresponds to the canon of Patchwell, and I'm going to run it and to create music based on that pattern and see if how that sounds, and see if that sounds well or not. So now it has already finished. I open the file, don't save, okay, and let me share with you. Okay, I don't know why you cannot see it. Okay, now. So now let me again put the speakers. Yeah. For now, we have created today music based on a sequence. If you listen to the previous music we created, is more. So I'm going to create some tests for all of this. I'm going to evolve a bit this code, and I would like I hope you have enjoyed this session, and that now that you are able to create music like Patchwell, now you can create your own composition in your free time. See you next week, and thank you very much for being there.